Welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good, so last session we have implemented we have cleaned up some stuff here and simplified some things, and we implemented the parsing of the non-virtual thunks and the secondary vtables, right? And we implemented some functions here, some functions somewhere. Get base classes, this one, for example. Okay, so what we want to do now is we would like to see what overrides what, and yeah. So the non-virtual thunks, let's take a look at one. Make sure you can probably so here type in for vtable, this one. There we go. Okay, so here we know that this this base class with this offset will have these things overwritten. So that means these guys will also be overwritten. These guys. Yeah. It is interesting that this sits here, and then we have these functions here. Object module. Here we have a pure virtual, and then an override. Okay, but this is the primary vtable, which will be encompassing all. This one contains all virtual functions that are part of this class, whereas these thunks here only contain some, right? That are relevant just for specific base classes at specific offsets, right? So these will help us to get intel on it won't help us to see some functions, right? So here, for example, we still have a pure virtual, and we have some functions here, but these refer to something that is not present here in those. So this must refer to some class that sits at offset 0. All right. And this as well, this one. Actually, let's look into update module, Visual Studio, MachOCodeGen. Oops. I opened the same solution twice. That's not what I wanted to do. There we go. Okay, we're looking at update module. No? Update module. No? Why is this not found? There we go. Okay. So. Okay, so this refers to module, update module, object module, object behavior, update module. Okay, so these are overridden here. This one is overridden here. Yeah. And these are, well, this one is not overridden. Okay, I would say we make a first pass. I'm still not entirely clear over the whole construct, but we have more information now, so hopefully we can figure out more things. Yeah. So we have generate classes from functions, process vtables. There we go. All right. So. Okay, how about we comment out this for now? And then we make a pass and we look for the secondary vtables. Let me see. Yeah. Okay. So I would say we put process vtables. Okay. So we say if vtables dot size is smaller than 2, then we skip that. Otherwise, we do for size ti equals 1. Let's do const size t vtable size. And then we do vtable I smaller than vtable size plus I. Maybe we give it a better name, vtable index. Okay. Okay. And then in here, we do vtable index. Then we do vtable vtable const yeah, and then vtable dot offset. We do class type get base class m classes vtable offset base class. Yeah, and then we say can we make it const maybe? Maybe not. And then we say base class index. We say we can make it const. And I think this one, we expect that this is not null pointer, right? Base class is not null pointer. And then we will classes base class. Yeah, class type. And then we do class base class type. Yeah. Oh, by the way, hold on a minute. Okay. Okay. So we are looking at base class type, yeah, and then we're looking at MV tables. Yeah, and then here we're probably looking at if do we expect a vtable? Probably vtable dot size larger than 0. 1. I think. We will see. If we hit the asserts, we check. Okay. So base class type vtable size bigger than 1. And then we will check base class type, base classes, no. Hold on. I think that this count should match the vtable count. So I think what we do is assert vtable.size equals maybe maybe we put base vtable equals this. Oh, no. Base vtable 0. There we go. Vtables. There we go. And then we now expect that vtable dot size equals base vtable dot size. Is that correct? Maybe. Base vtable. Why is this? Vtable has no member size. Vtable dot m entries. Yeah, m entries. And then we do a for size t, I equals 0, I smaller than vtable entry size plus I, and then we will check if 0 maybe we say entry index okay, so if entries equals no dot is pure virtual is pure virtual, and then we if is pure virtual pure virtual, and then we say if how about we make an alias here, base entry vtable entry base entry equals that base entry dot that if this name dot empty, then we assign it, otherwise we will assert. Here we say base entry dot name equals vtable base entry. Let's do vtable entry const entry vtable dot m entries entry index entry dot m name. Hold on. Do we actually set this name already? This name. Wow, I search for this and it searches for pure virtual. Why? There we go. Vtable entry. Yeah, we already set it here. Here. here, and here. Okay, then let's get back here. Entry.mname. There we go. I'm not actually, hold on. I think it needs to be entry mname, retail entry, wait. Actually, I think it needs to be find. We need to remove the context name from this. Okay, but we can already test here a little bit. So my expectation is that this assert will be hit for now because it's not quite right yet. So let's comment this out for now. Okay, but I think we can already test this so far to see if this already leads to something to begin with. Let's see. Let's see. Good. So class type, overridable. Vtable. Okay, there's nothing to do here. Let's put a breakpoint here. There we go. Good. So vtable index. So vtable offset is 4. The base class is found. Yeah. Base class type. We have here C sample sound. Now it expects that the vtable size is 1 or bigger. Then we take the first vtable. Yeah, entries. Yeah, okay, so and so this one, we now expect 3 entries here and 3 here. That matches, that's good. Yeah. And then we go in here. Entry. This one is a destructor. It's not a pure virtual. This one is also not. Actually, we expect... no, we don't expect. If base class is pure virtual false. Yeah, we should probably have a check here. If entry.m is not pure virtual and the other one is pure virtual, only then do something here. Yeah, let's put a breakpoint here. There we go. Okay, there we have some hits. Let's see. Okay, so idle is here a non-pure virtual. It's overridden. And here we have the pure virtual. The name is empty. And so what we do now is we assign this listener object idle to this entry here. But with the listener object name, which is not what we want. We want to just have the idle parentheses, right? Okay, but apart from that, let's see if it runs through without errors. I have the suspicion that there's some error, but it shouldn't. Let's see. Okay, there is some error. Okay, let's see. Aha, base class is null. Oof. Oh, that's not good. Class type, terrain tracks. Base class. Base offset 4. Okay, we have to look into this, I think. I don't know what's up with that. 385. Let's clean up here. Classes 385. And what was the other one? 1046. Oh. 1046. There we go. Alrighty, so base classes and let's see. 816. Base class is 0. This one doesn't have a 12. Is that because, hold on. Do we have to calculate the base differently? So hold on. So here, class type. So the base here is 0 and here is 4. 0 and 4. The first one doesn't have anything. The other one, could it be that we have to add the 4 to both of these? Maybe. Not sure. Maybe. How far are we in here? You're already quite far in. I would have expected that it failed earlier and not so late. Base offset 4. Base offset 4. Base offset. Yeah. Okay, so what I could... Wait, hold on. vtable. Vtables 4. So there is 4, 12, and 20. 4, 12, 20. 20. So are we looking at 8 and 16? 8 and 16, it could be here, yeah. So my suspicion is that here in this function, maybe we need to carry this base offset How do we do it? Get base class. Base offset. Base offset. Maybe we simply need to take this offset, so it would be 0 or then some higher number, and then we just add it here. Maybe. I'm a bit suspicious because it asserted so late here, very late. I would have expected it asserted much earlier already, much earlier. Let's see. Let's see. So base class, it's found, yeah. That's also found. Okay, so far so good, yeah. Yeah. Four. Okay, let's see. Oh, we got a different hit now. Okay. What do we have? Classes. Oh, we are here now. The same thing. Okay, 4, 12, 20. Entry 6 and 2. Okay. Terrain tracks, render object class. Terrain tracks. That's unexpected. Offset is 12. So we have returned base class, multi-list object class. Terrain tracks render object class, vtables. 0, 4, 12, 20. 6, 2. 2. Okay, let's ignore this one here. How about let's see if this runs through first. This one. Yeah. One assert at a time, right? Yeah. Oh no. Oh no. Uh-oh. Offset 20. It's that again. What's going on here? So it's 385 and 1046. Yeah. Oh boy. So we have 8 and 16. Offset 20. Why is this null? Oh, this is a bit tricky now. Vtable offset is 20. Vtable. 4, 12, 20. Four, 12, 20. I think there's still something wrong in here. Let's copy value. We do if class type dot name equals this, then int a equals 0. Put a breakpoint. There we go. Okay, good. So the offset is 4. Let's see what happens. Oh boy. There we go. 4, 2, 0 and 4. Base offset 4. Okay. 4. Base offset. And then what does it do here? M classes, class index. Huh? Right. 4. So it looks into the next one. Okay, base offset is still 4. Base class is 0. Okay. Okay. 0. All right. Okay, next 4, 4. 4, 4. This looks good. So we do this, break and return. Okay, so this looks correct. Next. Next. Good. So so we have the 2 base classes. We're looking for 12 now. We're looking for 12. We first look in here. All right. So this one returns null. Okay, second base class. 12, 4. This is not a match. We look now into the child, and that is 12 plus 4. Oh, hold on. 12 plus 4. 12 plus 4. Oh, I think there's an error here. We probably want, hold on, base offset is 12. We're looking for 12. Looking for 12. Maybe we have to do base offset minus this one. Could that be? Minus? Maybe that's it. Hold on. We should probably say assert. Oh boy. Assert this one base offset needs to be larger than this, I think. I mean, it shouldn't reach 0. So I think this one needs to be larger than this always. If it would reach 0, then that would be strange. Actually, hold on. Base offset. Or equal, larger equal. Yeah. Let's see. Let's retry. Retry. Okay, there we go. So, get base class, offset classes. There we go. Wait, we are just looking for the first one. That's fine. Okay, continue. Okay, so the second one, let's go. There we go. Okay, so the first base class, this one is bigger than this one. Base offset bigger than, yeah. Okay. Let's go in here. Base class is 0. Okay. Okay. There we go. Okay, next one. 12, 4, no. Okay, so 12 is bigger than this one. Maybe it can be bigger. I'm not yet sure. Okay, so now we look at base offset 12 minus this one. Base class result. So this should now return a result. The first, the number 8, it should return. Number 8. 12. Yeah, let's see. Okay. 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 Okay, and so now this should also contain base class vtable. So this has 6 entries and this has 6 as well. Okay, so this might be correct now. And then so next iteration it should also return a base class. Yeah. Offset 20 and it has this one 16. Yeah, okay, I hope that this is correct now. Okay, let's see if that runs now through without errors. Yeah, it does. Okay, that's already very promising. Okay, now we remove this continue here. And then we see if this assert also passes, which it should. It should. If it does, I think that's a great sign then. All right, let's see. Yeah, it passes very well. Very well. Shouldn't have set that breakpoint then. Where are we? Here. Okay, great. Then let's put a breakpoint in here and let's see what that does. Okay, so we are saying that this is not pure virtual, this is pure virtual. The name is empty. And here we see we have this thing, listener object. Okay, and our base class here, it's C sound object. Yeah, C sound object. Okay, name, class name, M name, class. Why is there class name, class name, class name? Oh. Okay, another question is, how do we assemble the name? We could use the class name or the name and then 2 colons and then the function name, or we just put the function name without this. Yeah. I would say we put it without, but we need to document it then. Yeah, but then it's inconsistent with the others. What's the time? Okay, well, we got quite a bit done already. I'm really happy with the progress, but I'm not yet sure how we do this here. We basically we need a function. I think we already did something similar here. This one. Yeah. I think we use the same as this one, right? Class name. parent name, this one. Class name. Not sure. I'm not sure. Yeah, we need to carefully plan here what we do. Actually, hold on. We should be able to exclude the name with this information here, right? M name. Yeah. So we take, I think we take class M name. Class type M name dot size. Put, hold on. Da, da, da. So C listener object. Yeah, I think what we have to do is we put here assert just to verify. Assert this equals colon and this plus one also colon, right? And then entry, we put dot substring this plus 2. Yeah. Could that be? Let's Let's see. Let's put a breakpoint here. Hold on. But we also need to say mname equals entry class type base class type dot mname plus that. Right? I think so. Let's see. Okay, so this should now become sound object. Yeah, sound object idle colon. Hold on. I think we need to remove this actually to include the colons. Yeah. Let's restart. Okay. Name. Yeah. Okay. So name plus, and now I cannot see what it is anymore. By int b equals 0, so I can put the breakpoints. Okay, see sound object idle. And it is a pure virtual, and we now have a name. See sound object idle. How about we make this here? Entry name. We probably need a function that create function name, make function name. std string, and we pass std string view function name std string view function name class name, and we have base class. Make function. Let's do old class name std string view new class name. Yeah. Okay. And then in here we do put this guy, and we say function name then we do old class name and new class name. New class name. That is return that. Okay, we have a problem here. New class name std string new class name somehow dot append. Okay, so this should be able now to say then base equals make function name. So function name is this one, entry dot mname. Old class name is this one. And new function name is this one. A new class name. All right. Okay, let's double check this. Load commands are corrupted. Yeah. Okay, there we go. So mname, that's a function name. Listener object, sound object. Yeah. Okay. So the name is now sound object idle. Yeah. And here is the same sound object idle. Okay. Then we can remove this here. And then this is simplified. And then here now we can put an assert. Base name needs to match this. So if there are two, if there are two that write over this, which I think can happen, then we have an assert to verify that it's the exact same, which should be the case. Right? Let's see if that hits. No. Okay, there we go. So idle snapshot CSC exverb. Very nice. Very nice. This looks very good. Let's see if this ever hits. Oh, we got an assert. Let's see, what do we have here? Function name, behavior module, get collide. Okay. 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 Right. Okay, so this doesn't work. Behavior module get collide. Behavior module interface. Entry. It's pure virtual. Behavior module. Maybe. Maybe. I think there are two ways. Well, one, yeah, the two way. Either we customly parse where the class name ends, right? Or maybe we just say only if the class type name matches the beginning of the function name, only then we take this. Does that make sense? Yeah. Basically, we say, but maybe. Maybe. But then I wonder if we miss any information. Yeah, I don't know. I would say, I'm not sure. Behavior module get collide. I think it's behavior module. I think it's safer for full coverage that we make this more flexible here. Yeah, okay, so right now it fails because the class name doesn't match this here, because this one uses the function of behavior module and it doesn't override it with its own, right? Yeah. Proof. I think we continue with this in the next session and think about it, how to do it. Yeah, I think for now I would take a break here. Yeah. Then next session we try to figure out how to do this thing here. Yeah. Okay, then I will take a break here. I wish you a great day or night. Until next time. Goodbye.